All right, we are back. This is PTXPO 2026.
2026.
Christina and I back at it again. It's been a hot minute.
It's been since 2018.
2018. That is
I was a lot younger then.
Well, we were all
So were you.
younger
You weren't
then.
as gray.
No, I wasn't close to as gray. But it has been a crazy few years. And what I think is really cool is that this year, we are bringing students to come see what manufacturing is all about, what mold making is all about, and what plastics is all about.
And actually, these students already know what manufacturing is about. So we're just kind of doubling down on what their interest is. And this is a perfect show to show them, I guess, the whole range of how plastic parts are made. From equipment to the auxiliaries to the components, the software. Yeah, I agree.
So the first thing that we're going to do is we're going to teach you that if you're going to be in the industry, you have to get engaged. So walking in and sitting in the very furthest back corner, pretending like you're not interested, is not a good thing. It's not a good strategy to life.
Everybody up.
Like when you show up and come in and make your presence felt. Don't sit in the back corner.
We're going to need your help so you can move up.
Don't sit in the back corner.
Thank you.
Don't sit in the back corner. They're getting it. They're getting it slowly. It's coming along. They're figuring it out. Here we go. Almost there. Yes. Yes. See?
It works.
It only takes encouragement, right? You don't have to yell at people, but it takes encouragement to get people to take that next step.
I agree. And you'll learn more.
Yeah. So, who do we have here today?
All right, so today, to get things off, because I know you guys like to probably touch things, you want to see how things work. So we have with us Dr. Mark Wolverton.
Not a doctor, but okay.
No, you're Dr. Plastics, right? Or Dr. Mold, we'll say. So actually,
see how quickly he said,
Yeah,
no,
I'm not
a doctor. No, don't.
You are in this industry for what you're going to show these guys today. So why don't you come on over here?
All right, let's hear it for him. Come on. That's how this works. Yeah. Well, he went from the side with the stairs to the side that has no stairs. Yeah. That's all right. That's what happens.
That's what happens when you've been in the industry for a little bit too long.
Sit down for a second. Let's have a quick chat, and then we'll do some interviews. He's ready to roll. I mean,
Hey,
hold on. Let's do this. All right.
I'm always sensitive to time.
Can you guys hear him okay? Yes. Yeah? All right, good. So, Dr. Not Dr. Plastics. How long have you been in the industry?
50 plus years.
50 plus years. Are your parents 50? Yeah, about, right? So, like, you've been in this longer than their parents have been alive. How's that make you feel?
Old.
Yeah.
That just means you have a lot of wisdom and experience.
That's where I was going,
I don't know about wisdom.
And look at the way you're dressed. You actually have fun every day.
I do.
Right?
I do. I'm here with Plastivan. Plastivan is an outreach for the chaperones and the parents here. Plastivan is an outreach to the different schools featuring positive plastic education. We're sponsored by the SPE Foundation. We have local sponsors as well. I'm based here in Chicago, despite my business card saying Danbury, Connecticut. That's a different problem. But we go around to schools, high schools, middle schools, elementary schools, and bring information about plastics and applications and chemistry and physics and job opportunities to the different schools for a way to carry through and improve plastics in your utility and the way you use it.
And it's actually a van.
It used to be a van. It's now a couple of boxes in the trunk of my car, or when I fly around the country, it's a 55-pound suitcase to get checked underneath. But at one point it was two vans, but economics being what they are, we couldn't keep them on the road.
Got it.
So we ended up doing the other.
So here's something that's really, really important. We don't want to waste your guys' time, right? Like, first of all, you're out of school, so you're happy, right? But there's many other things that you could be doing. And so don't sit there bored and wondering things that we can answer, right? So if you have a question, feel free to just stop us. Unless the question is like, why do you suck? Like, if that's the question, just keep that to yourself. But if you have questions or thoughts or opinions, like, just raise your hand, shout it out, because that's what this is for you guys to be able to grow and learn and be ready for that next step of your careers.
So just to help me out, which school is represented here?
Leiden High School.
Leiden High School.
High School.
Where are you located?
Franklin Park, down the road.
Northway.
Easy to get here.
I like that
Great.
guy.
I like that. Okay. Is this a technology class or a science class or science?
Metals.
Metals.
Yes.
Oh, so we really have to change your mind. Well, guess what?
Exactly.
Well, it's curious that you would say that because when I was a little older than you and entered into college, I actually started to pursue my degree in metallurgical engineering. I thought I was going to be in steel, like my dad. My dad was in steel. Turned out he was one of our country's leading experts on plate information, including armor plate. So in the 1970s, I kept on watching the steel companies with which he was associated go bankrupt and close, and saw my dad change jobs several times. And so I adapted, and so did my school, and we had a couple of credit hours in polymer science as well as ceramics, as well as in non-ferrous metallurgy, as gold and silver and copper and platinum and stuff like that. So as I graduated, I was debating between going to work and going on to graduate school. My professor advisor grabbed a hold of me and said, "Mark, I need a resume." Well, at that time, you used to have to type them up, send them off for a week to get them offset printed in batches of 100. But our department had this wonderful invention at the time called an IBM Selectric Memory Typewriter.
You guys know what a typewriter is? All right, cool. I mean, I'm sorry.
It
but
was
you have to
a
know.
precursor to the printers that you're used to today. So, took my resume, gave it to the department secretary. She typed up 5 copies, typed one in, we proofread it, she made the corrections, and then spit out 5 copies. Sent it off. I got a phone interview. I got an in-person interview. I got a job offer at the top of my class working in plastics, in plastic composites. So much for graduate school. I went on to do applications development, technical service work in compounds and composites. Well, I came home Thanksgiving and shared with my dad what my new career path was going to be. And he said, "So you're displacing steel?" I said, "Yeah, that's kind of the idea, Dad." He said, "Okay, we'll just cut you out of the family." So that lasted about 6 weeks. Then he realized I'm probably going to make more money and choose his nursing home, and let me back in the family. So that was my path. So if you're looking at metals, metals are an incredibly important part of the plastics industry. You've seen all the stuff here about mold making and mold development, and most of the machines are involved in metals. But I'm here to talk a little bit about how plastics interact with those metals and the metals interact with the plastics to work together. Besides, we have a little bit of fun.
I love it. Let's get to it.
All right, let's do it. All right, let's shut this one off.
All right.
Do you need me to hand out stuff?
We won't.
Okay.
All right.
Okay.
So this, let's see if this works.
So I promised you a little bit of fun. All right. Who likes chemistry class? Good. Okay. When we do chemistry,
Oh, geez.
okay, there's a lot of serendipity and a lot of opportunity that comes around. A little bit of history lesson though. Okay. As we were looking at material science back in the 1800s, we had a couple of professors and teachers that would say, "I believe that things like leather and skin and hair, for those of us that have it, it's all right. I wasn't looking at you, I'm talking about me. And I admire Christina. So, are made up of things that are called giant molecules, macromolecules is what Herman Staudinger called them. People said, well, we can't observe that. Victorian scientists insisted on looking at it directly. So they would do a lot of direct experiments. They put that aside and figured it out. Well, we were looking for different materials to work with, and they were doing experiments, and typically they would do experiments at home, okay, because they had home laboratories, not commercial laboratories. Christian Schoenbein, Swiss scientist, was working with acids at home one day, and he had a spill on the floor. So what do you do when you have a spill on the floor? You wipe it up, right? What he had to wipe it up with was a cotton towel. He hung that cotton towel up next to the wood-burning stove to dry out. And like a good guy would, okay, we all would do that, right guys, girls? Yeah, hang it up. Not to upset Mrs. Stavanger or mom. Okay? And it turned into a stiff sheet, just like any kind of denim does when it dries out. He looked at it and said, didn't stain, it's stiff, it looks right, I'll take it down and I'll rinse it out. As he took it down and rinsed it out,
I didn't realize we were going to have danger today.
well, you're
We
not
might get in
gonna
trouble
make
for
it.
that.
That's why I held it up. Okay. He had developed nitrocellulose. Okay, nitrocellulose then became used for a lot of different applications around the house, such as picture frames, Christmas trees, tree ornaments, I should say, candlestick holders, other decorative devices. All right, but do you think there might be a problem with nitrocellulose in those applications? Yeah, a lot of house fires happened in the 1800s, okay? So people looked at that and said, maybe there's a different way to do it. A lot of other people got involved with it, both in sporting goods and in industrial applications. John Wesley Hyatt won a prize at that time, $10,000, today a little bit over $2 million, for the development of celluloid to replace ivory in billiard balls. So this is all part of the technology and the history that we went through. It was all individual contributions, people working in it. Nobody necessarily had degrees. People would be carrying these things forward. Other people were looking at other experiments. I have a sample here. We can pass it around a little bit later. You can come up and pick it up at the end of the program. This is natural rubber. It comes from a latex tree. It's not polymerized. You can feel that it squishes. Why was this important at the time? Well, if anybody, does anybody play golf? Okay. So, have you heard of the feathery? Okay. The feathery was the primary golf ball of the 1800s. Okay. It was a satchel of leather, about the size of a golf ball today, stuffed with a liter, a stovepipe pack, but a liter of chicken feathers.
Let me pass this around.
Okay, good. So you can imagine you've got a liter bottle full of chicken feathers being stuffed into a ball this size. It's kind of an intensive work. So people discovering rubber said, well, if we polymerize this and carry it forward, maybe we can have a new golf ball. And they had developed a gutta percha. And so that technology leads to today's advanced golf balls and multi-purpose balls. So again, sporting goods carrying forward. And if anybody plays soccer, football, hockey, field hockey, volleyball, you're wearing protective gear, you're taking advantage of polymers to help protect you and give you good sport. There's lots of other things that are involved in polymers. I'm not going to go into the entire program, but again, for the teachers and chaperones, this program is about 45 minutes long or a little bit longer, timed to the period of your class, and repeated a couple of times when you bring us in.
Did you guys know that there was natural rubber, like rubber trees? Yeah? Some yes, some no. I didn't know that there was a rubber tree. Did you know there was a rubber tree?
There's a song about a rubber tree.
There's a song about a rubber tree?
Yes,
there
there
are
is.
several songs about rubber trees. And then if you follow...
I listen to different music.
Well, yes, a lot. But if you look at what Thomas Alva Edison was about, we know Alva Edison for the development of the light bulb, right? Okay, we also know him for direct current. Did you also know that he made tremendous investments in trying to figure out how to breed rubber for tires, along with his buddy Firestone? Okay, so they were doing that kind of work. And if you go to his Fort Myers estate,
It's about the rubber tree plant.
you can see some of the laboratories that were involved in developing rubber. So that's one of the polymers we deal with. There's lots of other history. What separates polymers from metals is that the metal structure, has anybody heard the term face-centered cubic or hexagonal close pack yet? It's your metal studies? Now you have to be metallurgical engineering, metallurgical science, probably a little advanced here. Those are the states of steel, whether they be hard or soft, and going through some sort of transition. So if you're looking at metals, there are kinds of clouds of atoms, all kind of circulating around each other. If you're looking at steel, and you hear about carbon steel, what they're talking about is carbon that gets infused into the matrix that makes up the steel atoms and makes it stiff. And that's why it becomes hard. Right? Polymers are very, very different. If you think about and understand what happens with polymers and materials, you have to look at carbon as an atom. Carbon in its atom has 4 places for things to bond. Hydrogen has 1 place to bond. So you can take a carbon atom and hook it up with 4 hydrogens. Okay? Anybody have an idea what that might be? It's methane gas. Okay? So that.
Did you know that was methane gas? Yeah?
You got that? Okay.
All right.
Now, where do we find methane gas today? Okay.
On the ground.
Sort of.
Animals.
Yes. What animals and parts? Cows.
Cows.
What effluents from cows?
Like food.
Farts.
Cow
Yeah.
farts.
Come on, just say it. We all like
No,
farts.
we're gonna say that.
They're fun.
Everybody
Excellent.
farts.
Yeah.
Excellent, right? Okay, so.
I'm not encouraging anybody to do it in here because it's kind of
Oh, it's
closed
happening.
in.
It's
And
happening.
it'd be bad.
So, we have 1 carbon surrounded by hydrogen becomes a flammable and explosive gas. If we take two hydrogens and two carbons and surrounded by hydrogens, we get a gas called ethane. Okay, it's also pretty flammable. We get three hooked together, it's called propane. Does anybody recognize propane?
Yeah.
Grill gas, heating gas. Okay? If we get 8 hooked together, it becomes octane. Who recognizes octane? Who drives? Who drives? It is a measure of the power of gasoline. You get 12, it becomes diesel. Okay, you get 25, it becomes base oil for motor oil. You get 200, it becomes candle wax. You get 25,000 long, it's polyethylene. All carbon and hydrogen, just the length of the chain and the way they entangle. So these are the ways that polymers differ from metal. When you look at it, you say, what's that crazy old man doing up there with Mardi Gras beads? You know, it's the solstice. These are actually models that I use to talk about polymers. When you talk about plastics and polymers, you talk about monomers, which are the building block, any one individual bead or point or cube. Okay? And then when you extend them and have many, mono means one, poly means many, you extend them around, I get a necklace. The different beads give us different polymers like nylon and polyethylene and polypropylene and PET, okay, and that gives us different properties and different applications. So that's how the polymer science comes in. Now, where you guys interface with that in metals is when you're building molds or building machines, you're going to build them so to accommodate the necessary flow properties and the necessary structural and heating and cooling properties of the plastic to make an article that we want to use. Cool? All right, so who likes to have fun in science? All right, so
The guys in the back don't like to have fun.
they don't like to have fun.
No, they just want to be bored.
They're
They don't want to have fun at all.
Okay. What's different about this balloon?
You got stick through it.
Okay, so if I gave you a balloon and I gave your brother or sister a skewer, what's going to happen?
Isn't that pop?
They're going to get popped, right? Because they're going to take and stab it. Would you believe that you each could possibly run a skewer through the balloon? Yes. You want to give it a try with instruction?
Sure.
All right. So
All right, you can stab things today. Did you know you were going to be able to stab things today?
So,
Justine wants to stab things.
all right. Justine wants to stab it, and so
You'll be our example.
and Christina did it a couple of years ago for being live on TV, and she was very successful at it.
It's scary. It's a little scary.
Oh, hand out the balloons first. Where the balloons go?
I got him.
Oh, got it. Everybody gets a balloon.
You're going to think you're going to pop it, but you're not.
Everybody gets a balloon. And when you get it, the balloon, I want you to stretch it a little bit. You're feeling a property called elasticity. Even metals, yeah, there you go, that's it. Even
fine.
metals have an elastic property that they recover.
Don't pop it, Eric.
But rubber, latex rubber in the balloon, I hope nobody's allergic to a Band-Aid here, will have the same sort of behavior. Now, what do we like to do with balloons? We like to blow them up. Once you blow them up to about the size of a cantaloupe. How big's a cantaloupe? I'll show you. That's about the right size there, Mr.
You think you're going to pop it, but you're not.
But about this
Got it?
big,
You done with that rubber?
if you blow it up much bigger than this, it's going to make
Wanna
this
try it?
part of the experiment really, really tough.
Yeah, I've done this too many times.
Then you're going to tie it up. If anybody has trouble with it, you know, you're high schoolers, you'll be able to tie it up.
You want to do it?
I'm just going to say if you can't tie a balloon, you might be in the wrong class. I don't think engineering and manufacturing is going to be your skill set if you can't tie a balloon.
Well, yeah, have a little bit of physics.
Throw that out there.
Okay, so the idea is you've all been given a skewer, you've all been given a balloon. You're going to get some hand lotion in just a minute. The hand lotion is really important. But before we do that, we're going to look at our balloon as scientists. Okay, if we hold the balloon up to the light, we can see that it's stretched and thin and very transparent around what I'll call the equator. But when we hold the end and we look down here at the knot, and we look opposite the knot, we can see a dark spot. And what that tells us is the molecule's not quite so stretched so far. So I'll demonstrate this. We'll pass around the lotion in a minute. You're going to take the pointy end of your skewer, the pointy end, okay? We're going to dip it in and out of our hand lotion. You're going to get a little bit on it. Down here next to the knot, not in the knot, next to it in the dark spot, we're going to place the skewer and spin it. And it should go in. Then we're going to look to the opposite side of the dark spot, and we're going to spin the skewer. Spin the skewer and press it.
Look at that. Look at that.
You guys ready to try it? Okay.
All right, when you spin it around, don't push the skewer towards your face, though.
Yeah,
Like,
push everything.
push it away from your face.
A little dab on it.
Yep.
Okay. Everybody, sorry we don't have enough
Stick it all the way in there.
motion for everybody to get one of
Stick
their
it all
own,
the way
but
in there,
we
yeah.
got enough to share around. She's got that side good. When you get it, give it a try.
Put the lotion on it.
For those of you that are
Oh, you did already?
ashamed
Oh,
to
okay.
make this society,
Oh, well. One down. One down.
Don't pop it.
Two down.
Ah.
Hey, I don't want to derail
It might-
too
it
much,
might
but
be-
while
it's
we were
hand
walking
lotion. It's
around,
nothing
we
more
happened
than
to
hand
run
lotion.
into
Ta-da! We got a couple. We got a couple. All right. All right.
Want to bring them up?
Yeah, that's good.
we brought them.
Oh, we want to talk to them.
We were just like, I'm like, I don't know what we're gonna do, but I'm like, you got to come over.
Yeah.
here.
Can
We're
they,
like,
can we chat with
yeah,
them?
no, we literally have.
We'll
them.
love that. We'll love that. Okay.
It's
Perfect.
like
Oh my gosh, it's
students
perfect.
we both had from East and West Side. And
So,
ended up they were
so Doc, as they're doing this,
Oh my gosh, bring him in.
what makes it so the balloon is not popping? Let's talk through this as Christina's coming back up here.
Okay, so for everybody that's got it, you can see the balloon, the skewer's up for not, but here's the demonstration of how it works. This is a model, come on in, this is a model of the balloon molecule. Okay, it's a bunch of chains that are
Three
linked.
students that are
And they're
working at
big.
Matrix from their this
So
program, so we're going
big
to bring them up and talk to
that
them
there's
about
gaps
it.
between them. As we take it, I remember I asked you to spin the skewer and press. As you spin the skewer and press, it finds space between the molecules or it allows the molecules to move out of the way. This is how we were able to pass the skewer through. For those that had result B, the balloon popped,
Popping. Yeah.
we ended up pushing on a molecule junction, and the molecule said, I give up. And since it's one
You popped
molecule
yours?
that makes up the balloon, it bursts.
I don't have enough finesse.
It takes a little, this is all part of how we learn, okay? It's not that you found a way to break the balloon, you found a way that you did pierce it. So that's okay.
I mean, you did find a way to break it. If we're just being honest, you did.
There you go. So that's how the science of this works. It's a great party trick, okay? And I'll share the secrets here. The balloons come from Walmart, so do the skewers. And the hand lotion is the cheap stuff, and you dare not use your mom's good lotion without asking. Anyway, was that my time?
That's great.
Yeah,
that's
that's
great.
it.
Let's hear it
Thank
for
you,
Doc.
Dr. Mark.
Dr. Plastic.
When we're done, if you'll pull the skewers out on your way out, we'll put them back into the table and finish up. I'd appreciate it.
Perfect.
All right. Let's hear it for them.
Thank you, Mark.
All right. So,
Good?
Christina.
Yeah, 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 yeah,
Oh, he's going down the stairs this time.
Yes,
Good.
yes.
Good,
Good.
good,
Smart
good.
man, smart man.
So,
Did you hurt yourself?
lotion all over. Well, you know, some people are looking for lotion. It's really dry around
It
here.
is dry
so
in here.
The lotion is a gift. Consider that just a gift. So,
All right, I got a special news alert. I just
You
have to
do?
do this right
All right,
now.
let's do that.
We have 3 very special people here in the front row.
very special. Did you know that you were wait, now they're like, wait, we're special? Yes,
Oh,
you
no,
two
sorry,
are
not you guys.
special, but we're not talking about you at this time.
We have 3 guys from these programs that are
Okay.
here that are working in the plastics industry.
All
This
right.
is fantastic. This is a wonderful surprise. So I think we got to at least get
Yeah,
one
come
of
on
them
up,
up here.
come on up, come on up.
Now you can hear everything from the
Let
horse's
them-
mouth.
Let them sit, they can use this microphone.
This is a perfect person to ask questions you want to ask about careers, money, what the
Oh
day
man,
of a
they
life.
all abandoned him. He went from, we have 3 special people to 1 sucker.
Oh wow. Maybe
That's
give
the
him
way
a,
that
give him
works.
a prize. Introduce yourself.
All right, come on, sit down. Let's sit down. I thought they were coming up here, so we'll sit down.
Okay, so I'm Angel Fernandez. I took a machining program that started my senior year in West Leiden High School. My first teacher was Miss Longstrut. So,
Who's here? That's good. I didn't know that. That's great.
so I only got into this industry because I took that class. I didn't know what I wanted to do after high school. I was actually going to go to school to be a nurse. That's not what I wanted to do, but something that kind of was persuaded onto me. But after taking the course, I got a job. Miss Longstrut helped me get a job, which is where I've been for the past 10 years. And I love it. You know, now I've progressed I've run a whole department at the company. I train apprentices.
What do you love about it?
Yeah.
It's different every day. There's a different problem, different solution to everything every day. I help the molding guys out as best I can. You know, I work, all the group of guys that I work with, you know, it's an enjoyable, yes.
What section of plastics do you work in?
The question is, what section of plastics do you work in?
So I'm mainly a mold maker, so I work in the tool room side. So we build the mold bases. We build the mold bases, you know, to make the parts.
And you guys are familiar with molds, right? Plastic injection molds? Yeah? Yeah? Nod. Come on. You
Yep.
can do this. Yes, 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 yes. Yes. Good. All right.
This is tough.
That's great.
You know, my department, you know, me, John, Adam, we build the molds. We all have our own duties. So I run what is called a sinker EDM. John, he runs a graphite mill. Adam, he's pretty much running every machine he can, trying to learn as much as he can.
So here's some things, right? What grade are you guys in? Seniors and juniors. And hoping to go to college, not going to college? What's the college? Raise your hand. The rest of you don't want to go to college, or you don't want to raise your hand. Which one? Don't want to go to college. Raise your hand.
You want to get right to work?
Yeah. All right. So for people that, like, they don't know what that's going to be, right? You hear stories about what it means to go to work. What was the biggest shock going from being a student to going to work?
So, when I graduated high school, I actually continued my education. I went to Triton College. So my job was able to work with me to pursue whatever degree I wanted to. And at that time it was to pursue a mechanical engineering degree.
Oh, let's stop you there for a second, because that is an important component.
Yep.
A lot of these manufacturers will pay for you to go to school if you still want to go to school for further education. That's a huge benefit in this industry.
Yeah, I agree.
Yeah, so I ended up going to school. So I would go to school in the morning, get out, go to work a few hours, complete whatever jobs I needed. And then my job was also sending me to another school in Schaumburg called TMA, which was a 3-year program. So I was going to school at Triton College, going to work, going to school in Schaumburg at TMA to get a certificate. I got a little burnt out, so I stopped Triton College.
Burned out, explain that.
It was pretty much long hours, all
Okay.
day, every day.
Everybody you need to set those expectations.
Yeah,
too.
so your morning started at what time?
So I was out the house 7 a.m., Triton College till 9:30, would work all the way until 5:30, go to Schaumburg, be there by 6, and then from 6 to 9. So from 7 a.m. till 9:30 p.m., I was out the house, school, work, school.
So,
and then-
what does that make you guys, girls and guys, feel like when he
Yeah.
when he explains his day back then? How does that make you feel?
A little overwhelming.
Anybody else?
Like my average day as a tech service engineer.
A driven young man, yeah.
Yeah.
I mean, it takes hard work, right? Nothing's easy, but it's rewarding, correct?
Yeah.
And there's nothing saying that you have to do that. There's
No.
plenty of people that just go to work and they get their job and they do their job and they get their paycheck and they go home.
Yeah. So then I had to choose what I wanted to do. Did I want to continue pursuing the mechanical engineering degree and then figure it out from there, or continue working, going to school at Schaumburg, get the certificate, and progress my career at Matrix, which is where I work now.
Go Matrix.
Yeah. So I chose continue working, get the certificate, learn more, try to take advantage of my company. I know it sounds
No, that's right.
bad, but try to take advantage of all that they're giving me. Learn as much machines as I can, do as much as I can for the company. And if I wanted to take it to another company, then I could. But I've been with them for 10 years now, and everything's been great. We're moving on to a bigger facility, so
Does that sound intimidating to you guys at all?
No?
No? Scott?
So, Angel, can you tell us how your apprenticeship worked?
How did your apprenticeship work?
They said, here's machine go step-by-step training.
So when I walked into the door at Matrix, I was greeted by a handful of guys that worked in the shop. I really only trained one-on-one with one gentleman. He showed me the Bridgeport. He's like, I know you know what this machine is, but here's what you're gonna do. Here's what I'm gonna teach you. It could be, he's like, you can learn your way, learn my way, learn the school's way. There's so many ways to do things. Pick one that you like and stick with it. But yeah, I pretty much worked one-on-one with a guy for 6 months, and then I worked in another department, and from there I pretty much took over that department because he was leaving. They needed somebody there. So I was, even though I was kind of new to it, I had to step up and run a department on my own, figure it out.
Was it scary for you?
It was. I made a lot of mistakes, but everybody at work pretty much, they reassured me, you know, mistakes happen. You're not going to get good at this overnight. It's going to take years. But just know if you learn from your mistakes, if, you know, that feeling you get when you make a mistake, if you can try not to make that reoccurring, you're going to be good.
That's
And
the
you-
reality,
yeah.
right? Like stuff happens.
Yeah.
People make mistakes, right?
And
Like,
you usually don't make them again.
yeah. You shouldn't.
No, you shouldn't.
Not the exact same mistake anyways.
Yeah. I mean,
Did you?
It happens every so often, but you know, mistakes happen. As long as we can fix it, work together, come up with a solution, it's all right.
Did you explain why you chose Matrix?
So I did actually go to 2 other companies, and Matrix just seemed, it was a small family-owned company. I see it, to me Matrix was, it was kind of more welcoming.
Okay, so you were looking for that, because that's another thing. Your options in terms of company size and
Yep.
the culture of the company, there's so many different environments you can get into.
Yeah.
So you lean more toward a small family supportive group than a larger manufacturing operation, correct?
Yeah, it just seemed like I wouldn't be lost in the shop, if that makes sense.
No, totally makes sense.
All right, so is there another one? Which one of these guys is the youngest?
The one at the very end.
The one at the very end. Let's bring him up.
Thank you guys.
Thank
All
you.
right, let's hear it for Angel.
But you have to give a shout out to Justine because he mentioned
I know,
TMA.
I know. We'll bring Justine up here in a
Yeah.
second and talk all about what
Did
TMA
you
is
did
doing.
you do that on purpose? Did you tell him to say that?
Yeah, she paid him. All right, here you go. All right, what's your name?
My name is Adam,
And where did you go to school?
East Leiden.
East Leiden. All right, look at this. Representing very
Yeah.
well.
Yes, sir.
What made you want to get into manufacturing as a whole?
So senior year, I took a metals class with Mr. Maddox, and well, I never really went, honestly.
You never went to class.
No.
What? Okay,
All right, so
Not the best example.
so
not at all.
so you never went to class.
I tried.
You tried.
Okay.
Yeah.
What do you mean you tried?
It was first period, you know.
So you didn't try
We have
that
a funny
hard.
guy here,
Yeah.
funny guy.
Yeah, you didn't try that hard.
I tried my best.
No, you didn't, because then you would have gone to class.
You're right.
Yeah, all right.
I
So,
Wait, and we have to note that you've learned that this will not fly in the work environment,
No,
correct?
no.
Okay.
yeah. And we'll get to that, right? We'll get to that point. So you went to East Leiden, you registered for the class, you never went. How did that help you get into manufacturing?
Yeah.
We were able, during our spring break, we took a internship, a bunch of different shops. I ended up going to Tro for, I think it was a week, 2 weeks, something like that. I like the environment. I like just working in general. And by that time, I already had a job, so I already know what working was like. And
Within a shop environment already?
no,
Okay.
just working. In
So you
general.
needed to see it to
I needed to
become
see it.
engaged.
Yes.
You're not the classroom guy.
No,
right?
I'm not.
Got it.
No. I mean, it's not for everyone.
Exactly.
Everyone has their thing they're with.
Yep.
But yeah, so I had that. And then after I graduated, I didn't really know what I wanted to do. but I still remember that I took the internship and I liked it. So I ended up searching for something similar, and I ended up here at Matrix.
That's awesome. What grade did you get in the class that you didn't go to?
Senior.
Senior?
Senior year.
No, but what grade did you get?
Oh, C? B?
You got a B for not going?
Probably a D.
Yeah,
I felt bad.
All right.
Oh my
yeah, all right.
something like that.
I mean, if you get a B for not going, golly, y'all better ace this class for showing up. That's all I'm saying.
You did not get a B.
Oh my God.
Well,
I do think it's interesting that both of them said they didn't know what they wanted to do.
Yes.
So if you feel that way out there, that's normal.
Yeah.
You're not expected to know what you want to do for the rest of your life.
So you go interview at Matrix, and the interview goes well. What does that interview look like?
It was me and our shop foreman, Mike, one-on-one. He was telling me what comes with working at a shop, being punctual.
And you're like, uh-oh.
Yeah.
Yeah. Being punctual, detail.
Was that intimidating? Like, what did you wear? How did you prepare for that?
I don't know. My dad, he's hard worker, so took whatever he wore, I wore.
Okay.
Yeah. So
What kind of questions did you ask of the employer when you were interviewing? Like, what were you looking for?
what was I looking for? What I would do basically. Because I know everyone in a shop has their niche, their thing that they do. I want to know what I would do as an apprentice. So, now I do a lot of different things.
How long have you been there?
8 months.
Okay.
8 months. What's the most rewarding part of working there?
Most rewarding, I would say, is seeing a job finish. Seeing a job finish, knowing you had at least some part in it. Like, if something breaks, I'll be able to make it. And just knowing, something that I made is part of that project.
And what does Matrix specialize in? Like, I know it's molding, I know it's mold making, but what kind of parts is that?
Medical.
Medical parts. So what I think is really cool is that, like, so many people want to have a hand in doing something bigger, right? They don't just want a job, they want to be part of something bigger than just working.
Yeah, that's makes sense.
And working at a medical product manufacturer, how does that, like, what does that do for you?
Just knowing you have a hand in saving or helping people, millions, you don't know. But, you're behind the curtains, you could say.
Yeah.
Yeah.
Definitely.
No one will ever know
Yep.
who you are.
I
but
once
you know you
I once had a story, a guy working for a medical mold manufacturer, and his wife was in the hospital, and he's looking at all the
Close your
tubing and the test tubes, and he looked at it and was like, I made that.
Yeah.
And it's saving my wife's life. Like,
Yeah.
that's what you're talking about.
Yeah.
You're a part of that. So thank you for your service.
No, yeah.
Right? You're making
You're a
Dr.
doctor.
D. Right? It is
Changing
awesome.
lives.
Yes. Let me ask you this, and maybe these guys are wondering too. What has this afforded you in life?
What has it afforded?
Like, what kind of life has this given you?
I'm comfortable now. I don't have to work as long. Even though I do, it's just I could afford to pay my car. I don't have any worries really now.
Isn't that good to hear?
Yeah.
How many hours do you work like a week on average?
How many hours a week on average are you working?
Most days I do 10 to 11. Some days I'll try to push it more. So
Weekends?
weekends, no, we don't work the weekends.
That's nice, huh? No
But
weekend working.
I have
That's
another
good.
job, so
So he works on
I
weekends.
work on the
Yeah.
weekends. Yeah.
So is there a lot of room for growth, like coming in like entry level in mold making or in plastics in general? Is there a lot of room for growth?
I would say yeah. You just try to take as much information in as you can. There's always something for someone. Like he has his sinker, he runs in the graphite. I'm looking more towards doing grinding, like surface grinding. So I didn't really know a lot of anything when I started. And Angel, he's my teacher. He's taught me a good amount, so I think I've learned well. There's a lot of room to learn. Yes.
Are they sending you to school?
Yeah, I go to the same school he went to.
Triton or TMA?
TMA.
TMA. Well, I'm more for TMA. Well, we're gonna have to talk about that. We're gonna have to dig into that. So when you're looking at what's your goal being in the industry? What's your next steps? Take Angel's job?
Yeah.
Yeah, right?
I tell the lead man that we have in there that I'm gonna take his job eventually.
Well, that's good.
We need that to happen. That's
Yes,
what
absolutely.
needs to happen.
That's what I was going to say, because as the industry continues to go, if we don't have people taking those positions, then it falls off. One of the things that you guys need to know is that your resume doesn't have to be perfect, right? You don't have to know all the stuff. What you have to be is curious, right? I'm sure when you went in for the interview, you didn't have all the answers. You didn't know how to do all the stuff.
No.
What was it that you think gave you the edge to get the job in that situation?
I think it was I just wanted to be better. I just wanted a better job for myself, stability, something I have a future with.
Yeah.
I mean, how many times have we heard from shop owners that it's not so much the skills to bring it to the table, it's the attitude, right?
Yep.
It's the work ethic. So it's something to think about.
And I'll tell you, I do all the hiring for our company. Somebody comes in with this resume that maybe they used on ChatGPT, they put it all together, whatever. I take it, I flip it over, and we talk. So when I tell you guys to come into the room, come in the room, right? If you're sitting in the back, then you're not open to conversation, and you're not being curious, and you're not putting yourself out there. The most important thing that you can do is look somebody in the eyes, give them a handshake, be authentic with who you are, and communicate clearly what it is you want to do, and be a person that they can rely on. So be on time to the interview, be respectful in the interview, speak boldly in the interview,
questions.
Ask questions in the interview. Nobody expects you to have all the answers, but they do expect you to be a person that they want to work with, and a person that they can trust and grow with over time, because everybody wants somebody to step into that next role and be a leader in their shop. That's what everybody's hiring for. So when you ask the question, like, is there growth in this industry? The answer is yes, but it's totally 100% up to the individual. If you want it, you can have it. Scott?
Research about the company.
Yes.
Yeah, do research about the company, yeah.
Yeah, I heard a story yesterday. We were talking about this with different people, and we were talking about horror stories of interviewing people. And they were interviewing somebody, and they're talking for a little while, and the guy just looks at him and goes, "So, what do you guys do?" Like, come in prepared a little bit. Like, pretend like you care, right? Like, care about the thing that you want to be doing. And I guarantee you that
Yeah, show up on time or show up.
Show up on time.
Oh, I show up early now.
That's good.
See that?
That's good. There's such a need for you guys right now, that for you to get a summer internship or whatever that looks like, the key is just go to the shop. Knock on the door, walk in the door, talk to the secretary and say, "I'm looking for a position. Can you help me?"
Yeah, I guess it is worth saying. Do you guys and girls know that you're desperately needed? Like, manufacturing is at a dire point where I think it's 2030?
Yeah.
Like, the workforce, most of them are retiring. Like, we need you. You're desperately needed. So this is an opportunity. I think so many doors will open up for you if you have the right attitude and you go into these jobs. They are looking for people constantly. We need people to be in manufacturing. Plastics, metal cutting, design, whatever it is. Really, the world's your oyster in manufacturing. If you just,
Absolutely.
but have you heard that? Like, in school, in your neighborhoods, are people talking about that the country needs people in manufacturing, or you're not hearing that? You're not hearing that. Mixed.
Yeah.
Well, we're here to tell you, we're desperate.
Yeah, so we need you. We need you. I need you.
Otherwise, all these jobs are going to go outside the country.
All right, let's hear it for our friend here.
All right, thank you.
All right, so we've heard about TMA a couple times. Let's bring Justine up, and we'll talk about TMA a little
Yeah.
bit and what that actually is, and how you guys can get involved in that as students and what that looks like in the future.
Yeah. Does anybody out there know what TMA stands for? I know it's changed over the years.
All right, this is Justine. Justine.
Good job, Matt. The Technology and Manufacturing Association. First of all, can we give it up for your teachers?
Yes.
And Mr. Maddox and Ms. Armstrong. They're the best. I remember meeting them for the first time, and you guys are so fortunate to even just have the opportunity to even explore this career path. A lot of high schools don't even have a shop, and that's what we're trying to fix. But.
Yeah. So let's talk about the TMA. What is your role at the TMA?
So I work on the education foundation side. So I'm the one who's supplying you guys your prints for the precision machining competition, and I'm trying to help your teachers connect you to internship opportunities at your local manufacturing companies.
Oh, I was going to say, so how do these kids interact? Can they interact directly with you, or is it
Yes.
through their teacher?
Yeah, they already interact directly with us. A lot of them have submitted projects for the precision machining competition that we're doing. So we have about 400 registrations already across 30 high schools in the area. So that happens May 7th. I'm really excited about it.
Oh, that's nice.
I am not judging your parts. Don't worry. Me personally, I'm not.
What kind of
We
parts?
have
What kind of parts do you get?
Do you guys want to share what you're making?
A lot of guys making hammers.
The hammers. There's a Schrader valve die. There's some NIMS projects. There's just
Turning project, cylinder.
turning, milling. Yes, all of the above.
Who judges
14
them?
different projects. Our TMA members are volunteers. They come in and they judge.
Which are all other shops, correct?
Yeah.
So future employers.
Yeah.
Okay.
Exactly.
Is there opportunity for students to come in and meet, I should know this, meet potential employers?
Yeah. Just email me directly. Like they're both saying, I don't want anything to be intimidating at all. I can give you guys my contact. Literally give me 3 bullet points about yourself, and I would love to get you in your local manufacturing company and take a tour, have a conversation, anything like that.
Does TMA do job fairs?
Yeah. Well, we bounce around to different career fairs, yeah.
And if you want to see Justine and I look stupid, I mean, everybody does, you can go on YouTube and look up Make Manufacturing Fun Again. And Justine and I go from shop to shop, and they teach us the who, what, where, when, how it's all done. And then they put us to the task to see which one of us would be the better employee. And we're continuing to put those videos out, and it's humbling.
Spoiler alert, Tony normally wins, but I beat him a couple of times.
What kind of things are you guys doing?
We've done everything from building laser welding machines. We welded.
Grinded.
I
beat him in that one, so I remember that
That
one.
was
Nice.
horrible. That was horrible.
Oh, definitely check
surface
that out.
grinding. What else do we do? We've been to quite a few companies doing lots of different things and just showing how difficult these skills are, that they're not nothing jobs.
Exactly.
Yeah. Justine is also a musician. You can download her music.
New song coming out, drop party at TMA. No, I'm just joking. It's so good to hear that you guys are having a good experience at TMA. So TMA has a whole training facility in our Schaumburg headquarters. So the idea is we get you guys connected to an internship. You get a job within a company, and then that company then sponsors you to come get your apprenticeship done at TMA. So that's what they're talking about when they're talking about going to school. So the office I work at turns into a college at night, and it's really cool to see all the different people coming through, and they're all different ages, girls, guys, and it's just encouraging for me working in the office all day, knowing, hey, we're making this impact, and thank you for just taking the time to advance your careers too.
And we also have, TMA also has a relationship with Judson.
Yes.
To do other kinds of leadership training and student training.
So once you get your apprenticeship program, you can go into the MLP program, which is the Manufacturing Leaders Program. That's a monthly session, and it's covering all different topics. It's for when you kind of, maybe you've worked your way, like Angel, through, now you're running your part of the business, and now they want you to maybe be upper management, and you would go to that, and you would learn how to be in upper management at your company. So there's a course catalog that is so wide and vast, and I mean, you can just never stop learning. As we all know, there's never an ending point to that.
The important takeaway here is there is tons of support.
Yes.
All you have to do is reach out. You never have to do any of this alone.
Support and opportunity.
Yep.
Yeah.
Absolutely. Thanks for what you do.
Oh my gosh, yeah, I'm having so much fun.
Is there a lot of opportunity just in plastics or manufacturing in general?
As a whole, yeah. So you're at this plastics convention, but this is really just to kind of show you guys a different sector of it. But No, in general, and we can set you up based on what you're interested in the most.
I don't know of any company right now that would say they're not looking for people that are interested and ready to work. They just don't exist. So while people are saying that it's difficult to get jobs, people are looking to hire you, right? They want to hire you and start early. So there is opportunity everywhere. Don't listen to what people say. Should we bring Scott up here? You want to talk to Scott real quick? We got like 5 minutes.
Yeah.
Let's hear it for Justine.
You guys have any questions as you're sitting out there?
All right, Scott is a little intimidating. He's old, he's big, but he's also really, really knowledgeable, and he's been all over the world doing these sorts of things.
That's right.
So Scott is a guy that, you know, he will tell you what it used to be like and what he's seeing today because he's in a lot of it.
He's seen it all.
Yeah.
Thanks.
All right, Scotty, tell him a little bit about yourself.
Well, guys, I'm Scott Peters. I'm the division chair, serving as a division chair of the Mold Technologies division of SPE. And SPE is the Society of Plastics Engineers. We are a fraternity, but that's my night job. As a day job, I own a company. I started as an apprentice mold maker a long time before you were even thought of as children. 1975 was the start of my apprenticeship. I too am a graduate of TMA, but at that time it was the Tool and Die Institute of Chicago. So the TMA is a great program, and there's a lot of things you can do. My career has literally taken me around the world. I lived for 10 years in mainland China as a mold maker, running a multinational corporation. Unbelievable.
Did you have to learn, did you know Chinese before you went there? I mean, now you do, but I said before you went there.
When I went to China, I knew two words. Ni hao, which means hello, and xie xie, which means thank you. It's all I knew. But in 10 years, you have to learn something. So here's the takeaway. Apply yourself and listen to what's going on around you and learn it. For me, I learned how to count. Now I'm selfish, I'm lazy. Learning how to count meant I had the ability to negotiate price, how many, 多少钱, how much money, 多少, quantity, and what day. So I had all three things that were necessary in running an operation or ruining an operation, because if the eye gets in there, it ruins it. But in running an operation that I could negotiate with my supply partners. That's where I started learning Chinese. Everything else happened after. Did I answer your question?
Yeah, you did. You did. Yeah.
Cool.
I met you when you were in China, didn't I? Or no, I met you prior to that. That was a long stint there. Why did you come back from China?
Well, sometimes jobs end.
Okay.
Sometimes jobs end. I was there for 7 years in Guangzhou, China. So you think, everybody says, oh, Chicago, that's a big city. I don't know, what do we have here? 3.5 million, 4 million?
Something like that, yeah.
Something like that. So Guangzhou is 17 million registered inhabitants.
Wow.
That's registered. So the government counts everybody. They have to have an ID card to be registered in the city. But there were also 4 million unregistered inhabitants. So we're over 21 million. I was there for 7 years, the company closed, and they moved me back to the US.
What's the biggest difference between what you were doing in the US versus China? How do they do it differently?
Well, okay, that's a really good question. Yeah. So in the US, managers have the autonomy to make decisions and make things happen. And that's great. But in China, all decisions come from the top. Whether it's the premier, Xi Jinping, telling the country what to do, or it's the managing director of a company telling every employee in the operation what to do. It has to come from the top down. There's no bottom-up ability.
Wow.
But I broke the rules.
I was going to say, I can't even see you thriving in that.
Because I'm a Yankee.
So your career has spanned so many years. What's the biggest, like what technology had the biggest impact?
Every day we see new technology. That's really an unfair question.
Well, what's your favorite then?
So I'll start at the beginning. When I was an apprentice mold designer.
Well, don't start at the very beginning
know.
because
We
he's,
don't have
he's
that
looking
much
at me
time.
like they got to go pretty soon. So
Okay, I'm sorry. I will though.
you got a long career. So
Yeah.
I know, but we didn't have EDM when I started.
okay.
We didn't have CNC. Everything was done on a decal, pantograph, duplicating from master models. So think about a mold maker sitting at a pantograph all day long.
Yeah.
And then they introduced this thing called a Drupenrein, and it had a hydraulic true trace on it, and it would use a stylus, it was nut controlled, NC controlled, but the stylus followed those same patterns. And then they said, oh, NC, it's the new thing. And I said, you gotta be crazy nut control. And we got 3-axis CNC and 5-axis CNC and wire EDM. And the stuff we can do today in manufacturing just blows my hair back.
So being the division chair of SPE, how do you encourage these students to get involved and get jobs and stay in the industry and move forward?
Apply yourselves. Never stop learning. I'm 50 years in the industry, 50 plus years in the industry, and every day I'm looking to learn something new. And when you get that job, just like Angel, just like Adam, John, I was listening to apply yourself and take the risk to take on a new challenge. If the boss comes to you and says, oh, Angel, I need you to take over the EDM department because the guy's retiring, don't say no. Say, I will give it my best shot with your support.
Yeah.
Love it.
Yeah.
That's a great charge for everybody as we get out of here. Christina, do you have any final thoughts for these students?
I just love manufacturing. I just really want you to walk away knowing that we do need you. And I hope you were inspired by some of the technology that you saw on the show floor. Does anybody want to shout out to anything in particular that they saw that moved them?
Mold mover.
Oh, okay.
I never even thought that would be a thing. So that's fascinating.
How about any of the presses? Did anybody grab a cool part that you saw being made in one of the presses? No?
You know what I'm encouraged by? I'm encouraged by females in this class.
Oh, can I?
Please, yeah, please. Yeah, go, yeah.
Yesterday, tell
yeah.
you a little bit about SPE. We are a fraternity, we're professionals, but we recognize excellence in craft. And yesterday afternoon, we had the opportunity to recognize the top apprentice in the world based on those that were submitted. And guess what? It was a third-year young lady from Lee's Summit, Missouri. She came in. Her name is Shannon Morgan, and what a
Sarah.
resume
Her name
she
was
has.
Sarah Morgan.
Sarah, yes, I'm sorry.
He's 50 years in the
Shannon, I'm
industry.
Irish, it's too much. But this young lady set such a high bar for the next apprentice of the year. It's going to be hard to beat, but it can be beat through application. We also recognize the Mold Maker of the Year, Mold Designer of the Year, and the Mold Repair Tech of the Year. These are global awards. Our Mold Designer of the Year flew in from Amsterdam, Netherlands, to receive his award. Now that's something.
Yeah.
And when you get to that level, when you get your name out there, you can go anywhere in the world you want to go. Sorry.
No, it's great. It's great.
That's a great way to end it.
But what I want to say is like Lorena's in the back, right? Like women in manufacturing is a good thing. It's a positive thing. I like seeing more of it. I like seeing more women in the booths.
Yep.
I like seeing what they bring to the industry. And don't let anybody tell you that it's a man's job or it's a man's world or it's a man's anything. Like keep pushing forward. The industry needs more females in it.
We need workers.
Yeah. We need workers. We need people that are going to do a great job. So you guys give us encouragement because you're here today. And you didn't just blow it off. And you I didn't see anybody fall asleep, which is really, really good. Either we're too loud or you were actually interested. So that's good. I know you guys got to get out of here, right?
Yeah.
All right. So if you want to get a hold of anybody, Justine will give you her contact information or you can get it from her teacher. If you want to ask Christina questions, Christina, how do they get a hold of you?
MoldMakingTechnology.com. So the industry, that's another aspect of manufacturing too. Sales and marketing. It's not just manufacturing jobs. We support by covering the industry to get information out there. So there's editorial jobs, sales positions, marketing. we have a publication, MoldMakingTechnology.com, PlasticsTechnology.com. There are things you can subscribe to free. They're free subscriptions to learn about the industry. So,
And if you have questions about the industry, she's the person, because she's been the face of the industry for,
and
I'm not going to tell you how many years, because she'll hit
connect
me.
you with shops that are looking for kids, looking for future employers. So keep in touch and go on those sites. MoldMakingTechnology.com, PlasticsTechnology.com.
And if you're looking for some content about manufacturing, we have a podcast called the Manufacturing Alliance, where we talk to U.S. manufacturers about what they do, why they do it, the challenges that they have, and what they're looking for. So we want to thank you guys for coming here, being part of this, for keeping the industry moving forward. Don't stop. Don't stop learning. Do what Scott said. Be curious, be engaged, be hungry, be bold, walk into the room, be confident, and just do it. Take it over. Thank you guys for being here.
Go for it. Thank you, guys.